So yeah, I'm Oskar Stenman from Magine TV. I'm going to do a short company presentation, and then I'm actually going to focus on the basically evolution of our data centers and like where we are today. Because who we are and what we do is either a very short introduction or a very, very long one. So I kind of changed it a bit there. So we're originally a TV streaming company, started in 2011. We started dealing with video on demand as well last summer, when we bought Netnod. Headquarters in Stockholm, yeah, a bunch of employees here. We do live and time-shifted TV, so we basically record everything 24/7 from all channels. We have a couple of hundred channels we actually receive, but we don't actually provide all of them on all markets. Yeah, a bunch of clients as well. I mean, it's web and iOS and Android stuff. We have a couple of markets running. We have one in a Swedish and German market. Those are the main ones we have right now. We have launched a beta in United Kingdom, and I think it's like a month ago, we launched in a beta through a partner in Thailand as well. We have a couple of physical data centers. Those are mostly used for transcoding, monitoring, and reception equipment. Here we deal with mostly multicast and basically just upload the transcoded the multicast streams, and then we upload the material to our storage, which is in the cloud. I think we have like 500 multicast streams. It's a couple of gigabits in total we deal with. Our cloud for front-end data centers and user-facing ones, where we host like web and everything, APIs, all of that. We also have storage there. We have two main ones right now. It's in Ireland and Singapore. We are going to launch a new one in Frankfurt soonish with the new with the environment I'm going to go through in a moment. So yeah, this isn't really about who or what we do. That way, I'm just going to focus on the actual environments we run right now. So, first environment we have. I'm actually going to need to go through a little bit of history here to actually get to the new, how we actually do it today, and why what we do today may be a better idea than other solutions. So, in the beginning we had a couple of servers. I mean, we had a couple of applications running. We launched each application on a single server. So if we want to launch like API or something, we need to set up a new host. We have some scripts to just set up the basics made for it, and then we push the API on it. We had a load balancer in front of each service, and then we had, so it was kind of a big hierarchy of services, a lot of services as well. Quite messy to deal with. It looked like this when we had, for example, deployed our environment. So lots of load balancers, a lot of manual config and stuff. It got complicated pretty fast. Stuff didn't really work as we wanted it to. So we went to in 2013 we went to version 2. We basically moved to use Mesos and Aurora for scheduling instead. Mesos and Aurora are pretty cool because you set up Mesos masters and set up Mesos slaves. Masters and keep track of all slaves. So slaves report resources like, hey, I have 10 cores and 16 gigs of RAM or something. So then you can, through Mesos, launch tasks or reserve resources on hosts. So sorry. That's pretty cool because if we need to like upgrade or need more resources, more bandwidth on host or something, since we're running most of this in Amazon, we can just add more slaves. We run the load balancers on the slaves as well. It's just an application. So everything is is very dynamic that way. I mean, CPU, memory, networking, or anything. We just add more servers. And get to my slides. It looks like this one is scaled up. It's pretty easy to manage once it's actually set up, but it was quite complicated to actually launch all this. We basically booted a standard Ubuntu image. We ran used configuration management to deploy everything on it, like push the mesos and all other toolkits we use. And we set up the logos and stuff with that as well. So huge number of states we actually push. And it was, yeah, it becomes quite messy because, for example, we started one host a year ago and we start another one today. They have different versions of libraries or tools and stuff, so that was a problem as well. We set, for example, Zookeeper to find, because all of this is coordinated through the service, which is Zookeeper, you see that here. So to find Zookeeper, you need to, yeah, we need to point it out somehow, and that was, we set it statically, pushed the config to an environment variable in the hosts, and it was, yeah, it doesn't really work that well when you start replacing hosts and stuff. So yeah, here's the Zookeeper. So the services, instead of using load balancers like in version 1, the services announce themselves to Zookeeper, and like, yeah, so API provides a web service, HTTP port, so it announces that to Zookeeper. The load balancer picks that up and just starts load balancing. So we can launch API on a random host and a random port on the host, and it will just, yeah, the load balancer will just find it that way. Yeah, so we have had a couple of problems with this. It's like we also need to be able to set up new environments, for example, to do load tests. It's not very good to run it on production environments. We may need to deploy a full environment at short notice. I mean, it may be a new market, new region, worldwide or something, or disaster recovery is also very important. So we need to have a better solution for that, because the version 2 we have been running has been takes quite a bit of time to set up to get everything right. And yeah, the automated setups breaks because updates and stuff changes, applications, libraries and stuff, they actually change versions. And then we have the human error as well. I mean, it's like people like me go in and change the load balancers, try some change in the host, get interrupted, forget about it, and then you have a change somewhere which you can't really track, and you may notice something in graphs after yeah, a day or two. It's not very good way to deal with this. So, yeah, solutions to all these problems are actually few and relatively easy. So basically just make it very easy to set up a new environment, and make it very fast to launch a new environment as well. Stop using the config management. So basically, yeah, don't do changes on hosts after you have set them up. And then the human error, so make it kind of read-only, or at least very easy to keep track of what you're actually running on the host. It means you launch a certain image, like you make like a build or something, and then you are actually sure that this build looks like this, and it's quite tricky to change the configuration of the hosts. So to pick, yeah, how to actually manage this without config management as well is quite interesting, because then when you remove that, we have no way of actually telling, like, you should run Mesos master and slaves, so you should run load balancers API or whatever, how to actually find those services. It's that's a bit tricky. So we went with Consul instead. It's a consensus building application. All servers in the clusters, they run Consul. It's actually pretty cool because Consul knows about services, so you can tell Consul, like, hey, this node runs Zookeeper, and then you can query any Consul node on a DNS port. And you just ask, like, zookeeper.service.consul, where is that? And you get back a list of error records. That one has a TTL of 0, so you get, like, yeah, you get updates in real time when something changes in the data center. So no DNS failover or anything really happening there. It has a key value store, so you can also store values in it, and you can write configs to it or something. So we actually move the configurations and stuff into Consul instead. we wrote a service that basically reads from Consul's key value store, creates an Upstart job. It launches the service, registers the service in Consul as well, so it can be found through the DNS interface. So yeah, so for example, Zookeeper, when we just push the Zookeeper Upstart job into Consul, the Upstart job basically launches a Docker container on the host. So we don't need to have the Zookeeper service installed on the host anymore, because we also went with Docker containers. Yeah, it's actually really simple to manage right now. And we also added Vault for secrets management. That's also very, very interesting. It can integrate to Amazon and all other kinds of services. So you have time to live on secrets and expiry times and stuff. So it manages all of that for us. It's pretty nice. So in version 3, we're basically doing the same thing as in version 2. We use Mesos and Aurora. We have, but we moved all services, even Mesos and Aurora and Zookeeper, into containers. So the hosts themselves, the image we actually have as the base image in the data center is, I think it's like 200 meg in total. It just runs Consul and Docker, basically, and yeah, the Consul Upstart bridge we've written. Consul is what keeps everything together. We don't need a normal configuration management anymore. We never really change configurations on the hosts besides starting an Upstart job or stopping an Upstart job. And it's pretty simple when we launch a cluster in this environment. I mean, we can launch many hosts, all of them are running the exact same image. We just have a tag in Amazon, we have a tag on the hosts. In our own physical data centers, it's the same image, but it's in our own physical data centers we have a set of like role master or slave or something through DHCP. So it's actually, yeah, it's a very homogeneous environment, basically. And then we basically just tell the entire data center, like, hey, run these services for us. So we don't really need to care about which host should be running something. We just tag Zookeeper, say, run this master, and all masters will just pick that up and run it. So it's up to us to run 3 masters if we need that redundancy, or 5, or whatever we need. The environment looks like this. It's kind of the same as version 2, but everything is in containers. From an application standpoint, we have, it looks exactly like the version 2 environment, because we created a Docker container which contains basically the entire, all the libraries and stuff we had in the version 2 environment. So when we launched the API, we launched it in a container that looks like the old one. And those environment variables we used for setting Zookeeper and stuff, those are actually regenerated on the fly now when we launched the container as well, so that's pretty nice. It actually works very well. So to basically summarize this, we can now launch a data center running most supported services. If we do this in Amazon, we just upload a CloudFormation template. It's a single template for the entire data center. Defines masters, slaves, and DNS stuff. And that takes about 20 minutes. Then we push Consul, like all the parameters to Consul, and then we have Mesos and Aurora and everything running in about 40 minutes. It's with load balancers and stuff as well. We're not deploying the API services and stuff on this way yet. So it's quite a lot of cleaning we need to do there. We also need to automate the setup of databases and similar. But we can actually go from a full decision today. We've done that, tested that, so we can actually go from decision to actually having a fully deployed data center in under a day. And the goal is basically, at least my goal, is to make it all in less than 1 hour. So I mean, you can grab a cup of coffee, push a couple of buttons, and it's done. Then you have a new data center capable of supporting an entire new region, similar. So we've actually been overcomplicating things a lot earlier. That's a huge issue we've had. So, yeah. Can usually simplify stuff a lot. I think that's about it. Any questions?
Hi, Mark Levy at Cloudflare. Well, first of all, this is all cool stuff, but I want to ask you a question to the side of this. Talk to me about what you think about network engineers and this type of technology.
Yeah.
Or system administrators and doing networking. The two have merged, if not better.
Yeah. There is actually quite a couple of nice things in this. We have actually running Bird on all our physical servers. So we have we're actually running OSPF in our physical data centers. I should have mentioned that actually in the slides, but this was a little short notice. So we actually run just deploy another Consul template. We just upload a small configuration which basically pushes a transit config into Bird. We actually run Linux as our transit routers in a couple of places. It actually works very well. So you can just push, you can basically push changes this way into Consul, and it will reconfigure Bird on the host, configure a secondary interface, and then you can plug in a transit in there. So if you need to move that transit, you just retag it instead of having. I mean, the config is there already in Consul. It's just change what host you're actually deploying it to. It's a lot of stuff around there that I'm hoping to get. I hope we will be able to go way deeper into later.
Very cool. Any other questions from anyone?
Cool.
Okay.
Thank you.
Hold on. I have a last question. So, how do you, when you set up a new data center that you mentioned, you can launch a new data center in 40 minutes.
Yeah.
How do you do the bootstrapping? Are you using configuration from an already existing data center, or is it completely, because I mean, I understand what you're doing here. I mean, you're removing configuration, kind of making, you have containers immutable, all of that, right? But you gotta kind of have a starting point.
Yeah, we actually moved the basically cleaned up the stuff we had in configuration management earlier. Now we apply that and make an image of it, and we do the same. We basically make two images currently, one for Amazon, one for our own PXE with the environment. There are some small changes in Amazon. We set roll through the tags in Amazon, but in our own we set it in the cheap options. Small changes like that. In our own data centers, we also run Bird, for example. It's the same, basically the same image. It looks the same for anything running on the actual image later. But we built this in advance, and then you have it's like this is build 112 of the image, and it looks the same in both environments. We can easily extend this to other as well. I mean, you just do small modifications. I hope at least for example Google, and you can watch stuff there as well if you want to.
Okay, so that's for different platforms, but when you decide to start one of these things, I mean, you have some initial kind of console configuration, right?
Yeah, we basically push that. I mean, you have to use a Git repo with a couple of bash scripts with Kelvin. So you basically just curl put into the Consul repo.
Right. Okay. So, but that's kind of a manual step. The very first when launching it is, and this is you have a human doing that.
Yeah, that's still true. But we are planning on. I mean, that's actually going to be kind of, or at least more automated later. But I mean, that still takes I think it takes 30 seconds to push the config. Depending on
yeah. No, I'm just interested. I don't know. It's probably rumors, but Google can't boot one of their data centers without another data center being out because it's all so complex and you can't really have all the configuration. So I'm very interested in bootstrapping perspective. What happens if someone takes out all your infrastructure? Can you actually get it up and running again?
Yeah, this is actually we can also. I mean, we mostly try this in Amazon, but we've also done it on physical data centers. So we can actually launch basically take a rack of servers, configure 3 as masters, all others as slates, and in the DHCP, point it to an image and then run. Then you have Consul everything up running in. I think it takes like a minute to boot it. And then you push all the configs. Takes another. I think it takes like another 5 minutes or something to download if you have 10 gig network into storage. So yeah, of course, you actually need to have the Docker containers and the image lines around somewhere. But if you have that, it takes a couple of minutes. I mean, 10 minutes, and I have Nessus and Aurora, everything up running on physical hardware. But then you actually have to install hardware as well, which is why I chose Amazon as the example.
Right. Thank Thank you.
Thank you.
Okay, well, we'll give you thanks again then.